Okay, for B12, we have a single slit experiment here, or question here. So we have light of a wavelength 633 nanometers goes through a single narrow slit. And it tells us that the angle between the first minimum on one side of the central maximum and the first minimum on the other side is 1.2 degrees. And it's asking what is the width of the slit. All right, so what we have is we have a single, oops, all right, so that's my slit, and we'll call that slit, the height of this slit, or the opening of the slit, we'll call that A. And we know that over here, I'm going to have a screen here, and I'm going to have, let's say this is my central axis, and I'm going to have a maximum here, like that, and I'm going to have a maximum here like this. Okay, and what it's telling me is that this right here, from here to here, so this angle from here to here, this angle right here is 1.2 degrees. So say 1.2 degrees. Okay, and for this experiment, we can use, for this problem, we can use equation, the equation on page 34, Q2.10. So Q2.10, and that says that theta is equal to the inverse sine of n lambda over A, where A is the width between the slits, n is so n would represent this first minimum. This n would be a negative of this first minimum, so these would be the orders. This would be here, if I kept going here, this would be the location for n equals 2, and this would be the location here for n equals minus 2 here. So I want to know, I know that this angle is 1.2, and so the distance from here to here, the central axis up to the first minimum, I'm talking about n equals 1, so I can say, okay, theta is equal to sine inverse of lambda over A. And I also know, okay, I know now that theta is actually half of 1.2 degrees because I'm really looking for this angle right here. That's what this theta represents, is this angle. This is theta. So so theta is actually equal to 0.6 degrees. And I know when, for the small angle approximation, when my angle is less than 1 degree, and it would be here, that sine theta is about equal to theta. So I know that sine theta is about equal to theta for theta less than 1 degree. Okay, so I have, that means that if I bring this over, this becomes sine theta is equal to n lambda over A, and for small angles that just means that theta is equal to n lambda over A. Okay, so what I'm looking for is I'm looking for the width of the slit. So I'm looking for A. So let's get A alone. I can multiply both sides by A, and I can divide both sides by theta. So if I multiply both sides by A, I get A over here is equal to, now n is equal to 1, so I've got lambda over theta. Okay, so now if I want to plug numbers in here, I have, so let's do it over here. A is equal to lambda over theta. Now this theta needs to be in radians because I can't have my number in degrees. I know my answer's got to be in meters, and so theta's will be in meters, but I'm sorry, lambda will be in meters, but theta will be in degrees. So I need to multiply this times 180 degrees over pi to convert this theta to radians. So this is what I'll be doing. So I've got 633 times 10 to the minus 9 meters over theta is 0.6 degrees, and then I have 180 degrees here over pi. And so when I solve, A is equal to 6 times 10 to the minus 5 meters, which is equal to 60 microns. So that's my width of my slit here. And you can see that this equation is a lot like the equation with two slits, right, where I had two slits and I had d sine theta is equal to n lambda. And notice here that I have a sine theta is equal to n lambda. And so what happens is if I actually had two slits, then the diffraction due to a single slit actually modulates my double slit. So I would end up having if I had two slits, I would end up having something that looks like this, where this would be the pattern for my single slit, and what I would have for my double slit would be something that looks like that. And it's interesting that, and so this would keep going over here, and this would keep going over here. And so what's interesting is that when I have a slit like this, it's small, my slit width is small, and so that gives me a big diffraction pattern. And when I think about the double slit, right, I have a bigger separation between the slits, and that causes a smaller interference pattern here.